This is a video on independent events. The question states, two fair six-sided dice are rolled. Let A be the event the first die lands on a 2. B be the event that the sum of the dice is a 5. And C be the event that the sum is a 7. First, determine if A and B are independent. And second, determine if A and C are independent. So to decide whether events are independent, we can take a look at the probability of A and B and see if that's equal to the probability of A times the probability of B, because that's the definition of independence for events A and B. So let's calculate. We want to calculate first the probability of A and B. A is the event the first die lands on a 2, and B is the event that the sum of the dice is a 5. Well, for the first die to land on a 2 and the sum to be a 5, that must have meant you got a 2 and a 3. There's only one way of doing that. So notice there's just one 5 on my table. This is a table of rolled values. Well, let's call this 1 through 6 as the rows to be the first die, and 1 through 6 as the columns to be the second die, and these are the sums. So to find the probability, we count the number of ways of A and B occurring. That's just 1. And then there are a total of 36 different possible die rolls, because we just take 6 times 6 is 36. So the probability of A and B equals 1 over 36. Now let's find the probability of A, that the first die is a 2. So now we just say, well, there's 6 dies for that first die. One of those is a 2, and that gives 1 over 6 for the probability of A. Now let's find the probability of B, that the sum of the dice is a 5. So now in our table, notice we can get a 1 and a 4. That makes a 5. We can get a 2 and a 3. 2 plus 3 is 5. We can get a 3 and a 2, or a 4 and a 1. And we count. There's 1, 2, 3, 4 of those out of the same 36 total. And then I reduce 4 out of 36, reduces to 1/9. So the probability of B equals 1/9. So now let's check to see if the probability of A and B is equal to the probability of A times the probability of B. Well, we plug in. Probability of A and B, that was 1 over 36. And is that equal to the probability of A, that's 1 over 6, times the probability of B, that was 1 over 9. Well, 1 over 6 times 1 over 9 is 1 over 54. And 1 over 36 is not equal to 1 over 54. So that's false. A and B are not independent. So now let's answer the second question. Determine if A and C are independent. So now we do the same thing. We look at the probability of A and C, and we see if that's equal to the probability of A times the probability of C. So now we just compute. Well, the probability of A and C. Well, A was the first die as a 2, and C is that the sum is a 7. For both of those to happen, we had to have gotten the first die as a 2, and the second die must have been a 5, and there's only one way of doing that. So the probability of A and C is 1 over 36. Now let's find the probability of A. Well, we did that already. Probability of A was 1/6. So we just have to find the probability of C, that the sum is a 7. Well, to get a sum of a 7, you can get a 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, or a 6 and a 1. And we just count those. There's 1, 2, 3, 4, 5, 6 ways of that occurring. So the probability of C is 6 divided by the total number of ways, and that's still 36. So the probability of C is 6 over 36, and that fraction reduces to 1 over 6. So now let's find out if the equality holds. The probability of A and C is 1 over 36. And does that equal to the probability of A, that was 1 over 6, times the probability of C, that was also 1 over 6, and 1 over 6 times 1 over 6 is equal to 1 over 36. So it is true that 1 over 36 is equal to 1 over 36. So that means that A and C are independent. So in conclusion, we can say that events A and B are not independent, and events A and C are independent. And I'm done with the problem. Thank you for watching this video.